Hello class, how are you today? Welcome to this lecture. Your lecturer is Dr. Susan Macharia, a lecturer in the School of Social Sciences, and today we are going to continue from where we had left last time. The unit is Social Statistics. The code is BED2116. Last time, we were looking at basic statistics we can use to interpret data, measures of central tendency, the mean, the mode, the median. And today, we are going to look at correlational analysis. And I've divided this correlational analysis into 3 parts. Today, we are looking at the first part, that is on the scatter diagram. By the end of this lecture, ladies and gentlemen, we are going to have achieved 4 objectives. First, we are going to be able to define some of the key terms we use in correlational analysis. We are going also to be able to describe some of the 5 types of correlation. Next, we'll also construct and interpret scatter diagrams for given sets of data. And lastly, we'll be able to see some of the strengths and limitations of a scatter diagram or a scatter plot within the context of social science. Now, I want us to be able to define a few things that are relating to correlational analysis. The first thing, let's get the term correlation analysis itself. What is it? Now, correlational analysis is basically a statistical method that we use within social sciences to find out if a relationship exists or not between 2 variables or any 2 characteristics of interest to a researcher in social sciences. It also helps us to be able to know how strong that relationship might be. It also, at some point, helps us to be able to quantify the extent of that association between the 2 variables. And please note that our variables or characteristics of interest must be measured in what we call the interval and ratio scales. For example, you may want to find out if there is any relationship between the number of hours that a student does his or her study and the test scores in this particular unit. We also might be interested in finding out whether there is any relationship between the level of income and poverty, or even the calorie intake and the weight change. Another key term I want us to be able to capture is the word correlation. Basically, is the extent of association between any 2 variables of interest. And normally here, we talk of two variables. We are using a word here. The word bivariate simply means, bi means 2, and variate comes from variables, meaning we are looking at the association between 2 variables. And a variable, which is also another key word that I want us to be able to define, is a characteristic of interest. Anything that we are interested in that changes or takes on many different numbers. For example, age, weight, level of income, area of specialization, and poverty level. Now, the next thing that we need to do, class, we need to be able to know how we can describe this relationship that we are analyzing. If we need to describe any relationship between 2 variables of our interest, there are 4 things that I want you to be able to get from this lecture. The first, the strength. Number 2, direction. 3, shape. And then whether or not there's a relationship that is statistically significant or not. In terms of strength, the strength is said to be strong or weak. But for you to know whether it is strong or weak, we have to get a rough idea about where to make a decision. The decision is around this number, 0.5. Anything that is below 0.5 is said to be weak. Anything above 0.5 is supposed to be strong. The next thing is that these values of the relationship take on, they can be any number between +1 and -1. So we can have a fraction, we can have 0, we can have a decimal, so long as it won't go outside the range of 0.1, which is negative, and +1. The other thing is the direction. The direction can be positive or negative. Other things that I want you to note about correlations, which are critical for you to be able to proceed, is that correlations provide evidence of an association between any two variables of your interest. And whenever you are working out the correlation, in statistics, we like using symbols, and therefore a correlation is always denoted by a letter R in lowercase, not in uppercase. When it is in uppercase, it has a different connotation. Ladies and gentlemen, that R has no units. And when R is positive, it simply means that there is a positive association between those two variables of your interest, meaning both are increasing or both are reducing. If R is negative, then we say one of the variables is increasing, the other one is reducing. But remember, they must be anywhere between -1 and +1. Now let's go to types of correlations. In my opening remarks class, we had said we are going to be able to learn about 5 types of correlations. Now, the first one, we are going to look at positive and negative. Then we have linear and nonlinear, partial and total, simple and multiple, and the list goes on. So, for this lesson, let's look at what we mean by positive and negative. Now, in positive correlation, both variables or those characteristics which you are researching about, they increase or decrease. And sometimes one increases, the other one reduces. Sometimes one increases and the other one also increases, or they both reduce. The other one that is important is the linear. Of course, when it is linear, when you have the quantities coming from the variables of interest, both of them can be given or summarized in a table. After that, we plot on the x and y axis, and from there we get the line. That's what we call a linear relationship. The other one is nonlinear. Sometimes you can collect your data related to some characteristics of your choice. And class, when you try to plot them on the x and y axis, you find we are not able to get a line, but we get a curve. Any other thing that is not a line is a nonlinear relationship. Now, the other two you'll do as part of assignment towards the end. So let's focus now for our next objective. As a way to start the statistics class, we must begin by learning what a scatter diagram is, or a scatter plot, and thereafter we'll be able to define it, draw, describe it, and anything of your interest. Now, the scatter diagram is the simplest method of helping you to know whether a relationship exists or not. And one of the things that we know about a scatter diagram, we usually present that diagram or that information in form of a diagram. And looking at the diagram, class, you'll be able to know whether or not there is a relationship. I'll show you how. Now, a scatter plot indicates whether a relationship exists or not. And it's a very important procedure in correlation analysis because that's where everything starts. You cannot just go correlating unless you have been able to see whether there is a relationship or not in form of a diagram. So what we usually do, after coming from the field to collect our data, in terms of any characteristic of your interest that you are interested in, for example, age, income, level of income, family size, anything that you want to collect, you come back, summarize your data in a table, any two interval or ratio variables. Then, by convention, class, anytime that you want to plot a scatter diagram, we always start with what we call the independent variable, and there's also dependent variable. The independent variable is the one that affects, and the outcome variable is what is affected by the independent variable. And therefore, by convention, when you are plotting, all those quantities that represent the outcome variable, they go on the horizontal, on the vertical axis. The ones that represent the independent or the one that is affecting always go on the horizontal. And once we do that, it is important to come up with a scale. Don't just look at those items and plot them as is. Develop a scale. I'll be showing you a few of the ones that I've made. Now, once you plot those points, you'll be required to be able to see or to study and see whether there is likely to be a relationship between those points or not. How? By taking a ruler, try and draw a line that passes through most of the points. If there is such a line, then we can say there is a relationship. We can be able to describe it. But if you find the points are scattered everywhere and there seems to be no way you can join or have a line passing through most of them, then we say there is no relationship. Now, anytime that we come up with that line passing through most of the points, we call it the best line of fit. And that line is a very important line because it is what in later statistics we are going to look at as what we call the regression line. And getting that regression line will proceed to getting or being able to calculate and establish its equation. Now, let's go straight now to a simple way that I'm going to demonstrate to you how you can come up with how to construct and interpret a scatter plot. Now, this data here was obtained by a student who went out to collect the data of participants by age and weight. The first one had an age of 43. The weight was 99 kgs. Now, the second client, 2165, and the rest follow. Now, if I want to plot a scatter diagram for this, I have indicated that if the researcher wants to find out if there's a relationship between the age and the weight, now you have to know what goes on what side. This one, the first one, is what you're going to put on the horizontal axis, and then on the y, the weight, which is affected by age, is what we are going to put on the vertical axis. Now, let's look at this diagram together. We indicated that on the vertical side, you put in the weight. On this side, you put the age. Develop a suitable scale. As you can see, I have cut that scale in multiples of 10, equal distances between each of the points there. On the vertical axis again, choose another scale or a similar one, and from there, you are supposed to plot the points 43, 99. So the first point, 43, estimate it, 99. That's the first point there. And all the rest. After plotting, remember the way we plot, class. We don't plot a point using a dot or a circle. You always put a point or plot a point by having an intersection of two lines to indicate like an X, a small X. That one, that point, that point, that point, all the way. So if you look at this one, we have 1, 2, 3, 4, 5, 6. Now on my graph, how many points do we have? 1, 2, 3, 4, 5, 6. So all of them are there. From there, take a ruler, see whether you are able to join all the points, or at least most of them to be on the line above and others below. And after trying, I found that this line is the one that summarizes that data. And you can see the slope of the line, it is going up. So when this line is going up, class, we say it is a positive relationship. And this line that we are generating by drawing the line, across the points here, we call it the best line of fit. Some people may call it the trend line. And you can see my writing here. We say this is a positive correlation. Now let's go to another example. Now in the next example, class, we wanted to find out if a relationship exists between the number of hours a student puts in their study and the test score in a certain unit. Say, for example, basic social statistics. So here we have 5 students. 1, 2, 3, 4. There are 6 even. 1, 2, 3, 4, 5, 6. And the hours they put, the first student put in 4 hours, he scored 45. Another one put in 8 hours, scored 95. Another one put in 10 hours of study, he got 85, and the rest follow. Now, again, we have agreed, class, that when you are plotting a scatter diagram, by convention, if you want to find out whether the number of hours spent affect the test score or the marks attained in the test, this one which is affected on the vertical, the one that is affecting on the horizontal. And choose a suitable scale and label your axis. So on this side, we have hours of study. On the vertical side, we have the test scores. From there, plot the points. The first one, 4 hours and 45. So you come here, 4, 45 is here. So all the rest of the points are there. Thereafter, you take a ruler, and when you are plotting, you are trying to draw the best line of fit, class, it's very important that you do not draw in bits. Take your pen or pencil and your ruler and draw that line once. Because the minute you draw in bits, you find it's no longer a line, it's going to be a curve or a line with some corners, and it's not acceptable. Now, this is the best line of fit, and you can see this point here. There's a point here I want you to note. This point here is 18, 100. This is 18 here, 100. That point is what was achieved when we have a student who is not within that range. So it's an outlier. Now, once you are able to draw that line, we call it again the best line of fit. And as we proceed with this unit, we'll be able to get its equation, because we agreed that this best line of fit is also, at this particular point, going to be referred to as the regression line. And we use this regression line for different purposes, which I'm going to explain to you when we get there. Now, from there, we can look at another example. It's unfortunate most of my examples, the lines are going up, but sometimes you'll find a line going in the opposite direction, as in descending, coming down. Now, in the next one, we have data that was obtained from individuals who wanted to know whether there is an association between exercise, whether the exercise they do impacts on their weight loss. Now, once again, it is the hours of exercise and the weight. So the hours again go on the. Sometimes a social scientist may be interested in finding out whether there is a relationship between the hours they put in during exercise and the weight they lose. A sample of this data is presented. We can see we have somebody who did an exercise for 1 hour, lost 8.6 kgs, 2 hours, 11.3, 3 hours, 15.9, and the rest continue. Now we want to draw a scatter diagram to represent this information. Class, by convention, we have agreed that the variable or characteristic which is affected is the one that we put on the vertical axis. So on the vertical axis, we are going to label that as weight loss. On the horizontal, we have the hours of exercise. Then, using a suitable scale, divide the axis accordingly, and on the vertical one accordingly. And please remember that anytime you do a scatter plot, it must be sizable. Don't draw something that is so tiny, nobody can be able to read it. After all, you want to see whether there is a relationship or not, and you draw a best line of fit. So if it's so small, you won't be able to plot your points. So after plotting the points, we have 1 hour, 8.6. If you look at here, on the x-axis, I have 1 hour, 8.6 is there. Then you go second, 2 hours, 11.3. It is there, and the rest are plotted. From there, take your ruler that is adequate in size to see how you can be able to draw a line passing through most of the points. Some will be on top of it, some will be below that line. And once you draw that line, it is what you are calling again the best line of fit. Now after that, we are supposed to interpret this line or this data, and therefore we say it is a positive relationship. Why? Because the line is going upwards. If it is negative, it always lands from top coming down. But if it is positive, going up, the other thing we need to see is that this best line of fit, as I've indicated, is what we call a regression line or a trend line. And later in our lectures, we are going to be able to get its equation or calculate its equation and use it accordingly. The next thing that I want us to be able to do, class, is to be able to see what are the strengths of using a scatter plot. Why do we use it? We don't do a scatter plot or a scatter diagram when we feel like. There must be an intention. There must be some advantages that the scatter diagram is going to have over other things in the correlation analysis. The first is that is the simplest way that you can use to find out whether there is a relationship between variables or not. Because if you're able to draw that best line of fit, whether it is going up, whether it is going down, or you find there is no way. If there is no way you can draw a best line of fit, then we say there is no relationship. If you find that the best line of fit is sliding downwards, then we say a negative correlation. Next, it is a non-mathematical way. You know, social scientists, sometimes we don't like maths, or we might find mathematics a bit hard, or we want to avoid it. But the good thing is that it is a non-mathematical method to study a correlation. And as I have explained, I'm very sure you find it easy to understand. Next, looking at the scatter diagram or scatter plots, we are able to see whether there's a relationship or not. So using now the correlation, we can be able to put a number on that correlation. But as far as the scatter plot is concerned, we just at a quick check see whether there is a relationship or not between the two characteristics of interest. The other thing is that it informs us about the direction of the relationship. It can be positive, negative, or even zero. Remember we said if it is zero, there's no way. You try to draw a best line, it's not working. But if it is positive, the line is ascending towards the sky. If it is negative, the line is going from up, coming down. And then the other point is that it picks the outliers very, very easily. So anything that is going outside, or any value that is not within the expected, will basically be able to isolate itself as an outlier. Now, let's go now to the limitations or the disadvantages of these scatter diagrams. The first one is that we are not able to establish the exact degree of correlation between any two variables of interest. Remember, we have two characteristics of interest. We have drawn the best line of fit. And we can see the line is either going up, as we had indicated by the three examples, or sometimes coming down, or there's no way. So we are not able to see the exact value. We can tell whether it is positive or negative, but this method cannot give us the actual number. The other thing is that it gives us only a rough idea about the relationship between the variables of interest. And then, even if there is a relationship between the two variables of interest, as you want to be able to study, remember, it does not tell us what is causing what. And therefore, one key limitation of the scatter diagram is that it is not able to show what we call causation. Causation means what variable is causing the other. This change that you are finding in one variable, what causes it, is just a change, but not a cause. So, during this lesson, I want us to be able to look at some of the key points that we are going to take home. First, we were able to define some key terms: correlation analysis, correlation itself, variable. I'm very sure in an exam you can tell me what they are if I ask you. Next, we were able to at least be able to describe some types of correlation. Remember, I had indicated there were 4 or 5. I explained 2. We'll be looking at the other ones elsewhere. We have also been able to draw a scatter diagram. I've given you 3 examples, and I've emphasized what you should put, the procedure you need, what items should go on the vertical, what items should go on the horizontal scale. And remember, don't just cut the line without a scale. A scale is important. We've also been able to see some of the advantages of a scatter diagram and some of its disadvantages. And therefore, for your assignment, I would want you to go out there, research as much as you can, and make short notes on some of on the following. One, under the types of correlation, can you read something about what we call simple and multiple correlation? You also need to read ahead and be able to distinguish between what we call partial and total correlation. So in our next lecture, class, we are going now to go to the actual correlation so that we are able now to establish the number between, the actual number between a correlation. If you have been given a set of data, remember a scatter diagram has just been able to tell us the direction. Is it positive? Is it negative? Is it zero? But now in my next lecture, I'll be able now to help you or present to you the procedures you need to be able to establish the actual number, so that when we say there's a relationship between this and this, then we say it is 0.5. How do we get it? What are the different techniques? That's what I'm going to show you next time. And I think we have come to the end of our lesson. Thank you so much for being there. And please don't forget the assignment. Thank you so much.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.